Hi, my name is Henry Segaman. I'm here at the Department of Mathematics and Statistics at the University of Melbourne, where we've got 5 large 3D printed sculptures permanently installed. So I'll talk about each of them a little bit and the differences between making these big sculptures and the smaller versions. So here we have the half 120 cell and the half 600 cells, two duals to each other. Now, eventually the idea is that we'll have sort of spotlights mounted up on this side of the wall, so that they'll project shadows onto the wall over here, and then we'll get shadows of shadows, because these are three-dimensional shadows of four-dimensional objects, and we'll have two-dimensional shadows of those three-dimensional shadows of four-dimensional objects. So that would be cool, but at the moment, so for the open day here, last week or so, we just had some sort of bike lamps that were shining over there. So here are some stills of what it looked like with the shadows going through them. As with the smaller versions, these have nice symmetries. So there's the 5-fold symmetry axis, 3-fold symmetry axis, and the 2-fold symmetry axis for the 120 cell. Also for the 600 cell, we have the same. Of course, since they're dual to each other, you get the same symmetry. So there's the 5-fold symmetry axis, the 3-fold symmetry axis, and the 2-fold symmetry axis. Let's move on down the corridor towards the other 3 sculptures are these surfaces. So in the yellow here we've got the Clifford Torus, and then the red one is the Klein bottle, and further down we have the round Mobius strip. So with all of these, the design is a little bit thinner than it was for the smaller versions. So, well, relatively thin. So the actual thickness of the lines is bigger than it was for the small ones. But the small ones are sort of getting near the limit of what the printing technology can actually do. These ones, in absolute terms, are a little bit thicker, but in relative terms, relative to the shape of the object, they're thinner. And, well, so it's thinner, which means that it's cheaper. If we just sort of scale everything up from the small versions, then so all of these are printed with shapeways.com, and they charge by volume of the material that you use. So if you just scale everything up, then the price goes up as the cube of the linear scale, which is very expensive. So these are a little bit cheaper than it will be otherwise, and we can get away with making it that thin and still have some quite sort of strong, safe. The thinnest bits are still quite strong. Let me say a little bit about the colouring. So all the small versions that we have are just white. We've got a photograph of some of the small versions on the wall here. So the white works well against, say, a dark table, but the ceiling here is white, of course, and so the contrast of white on white wouldn't work as well. So these are all spray dyed rather than spray painted. There's a spray dye you can get in spray cans, which they're actually used for changing the colour of your car upholstery. And they work very well for this material because the plastic is sort of porous, and it means that the dye soaks into it rather than, it's not on the surface so it can chip. It soaks into it and you get a really sort of bright, permanent, durable colour. Last one over here is the round Mobius strip. This is the biggest of all of them. The shape of the printer that they have is actually important here. The bounding box for the printer is not a cube, it's actually rectangular. And so this one sort of, in a way, has the least symmetry. So you can fit this sort of rectangular cuboid shape into the printer and get it as large as it is. So 5 colourful, large 3D printed sculptures at the University of Melbourne.